So on 5.7, if you look, they've divided that whole circle up into all these different arcs, right? X, 3x, 2x, and 4x. Okay, so they're all divided up. Are they getting cold now?
Yeah, but it feels good in here.
It was 76 in here just a minute ago. Okay, so they divided that whole 360 degrees up into all those, arcs. So wouldn't all the arcs added together give us 360 degrees? Because that'd go all the way around the circle. So if I remember correctly, we had done that much of it where we had said x plus 3x is 4x, plus 2x is 6x, plus 4x is 10x. And if we divide, but we get 10x is equal to 360. So if we divide both sides by 10, we know that 1x is actually 36 degrees. Did we already do that? Did we do that, guys?
We already did 5 and 6. We're on like 7.
Okay, so find the measures of the angles formed by the chords. So what we had to do this much first because we need to know what the measures of the arcs are. If you remember, where do the angles lie in this circle? Are they inside the circle or outside the circle? Inside the circle. Okay, so we were supposed to find all these different angles. They're inside the circle. When they're inside the circle, do you remember that we add the two arcs that they intercept and divide by 2, and that gives us the angle measure? That's what we were talking about on the notes. It's that easy to just look at it and say, I just got to add the two arcs that they intercept. So I need to put the B and the D here. Okay, so let's list the angles just so we know, especially what we're talking about here. So CEA, the vertex is at E, so it goes in the middle, right? Well, that cuts into the two angles the two arcs are X and 2X. So X we know is 36 degrees, and 2X was 2 times 36 is 72 degrees, right? So if I use the formula, I just add 36 and 72 and divide by 2. So if you add those up, that's like 108 divided by 2. So that would be 54 degrees. So we're just kind of using that formula, but instead of me freaking out about the formula and getting all, I don't understand the formula, aren't we just adding the two arcs and dividing by 2? That can take the stress out of a formula if you understand what it's doing. What do you know? CEA and BED, what do we know about those two angles? What kind of angles are they? BED and CEA. Look at your, probably would help if you looked at your book on page 512 because you'd get a better picture. I can mark them up here. Aren't they directly across from each other? What do you call those? Huh? No, do you remember they're called vertical angles? And aren't vertical angles always the same thing? And so wouldn't that one also be 54 degrees since it's a vertical angle to the other one? They want me to also find BEC. So let's write that. Let's write that one down. BEC there. Now, if I know that if I know that BED is 54 degrees, I could go plug in and I can use that formula again, but I don't have to because look at this. If I draw BEC and BED, this one's 54 degrees. What do we notice about those? What's special about those two angles? We've studied it before. Why am I highlighting this? What do they make together? Don't they make a linear pair? Or don't they make a line? So what is a line? How could I find it without going and plugging in all those X's and doing that formula again? What would be an easy way to find that? I don't have to use the formula once I've used it once. What is a line? What do the two angles in a line add up? It worries me that I'm not hearing any responses. I know some of you are working ahead, but some of you are not. No one has their... Yeah, look for the relationships like that. Once you've used that formula one time in that angle and you found in that circle and you found one of the angles, You can find all the rest of them without the formulas because you can say, well, there's vertical angles going on, and there's things that add up to lines. So I tried to pull that one out. There on the bottom, if you were following along, you can see that, if you were following, you see what I did there. But, you've got all these relationships, so you don't have to use all those formulas for the arcs. You can actually just use it one time, and that's what I did. I found CEA first, and once I found that, I knew the other one across from it was the same because it's a vertical angle. And then I could use the fact that two of them together make a line to find the other one. And then across from it, it's a vertical angle, and it's the same. So we don't have to use those formulas just because we can if we don't want to have to get, wouldn't that slow you down using those formulas, I think? It wouldn't hurt. You'd get the same answer, but I'll go ahead and label in red the arcs that they give us. They tell us that this one is 100 degrees. And again, look at the book if you can't read the iPad because you can read the book. 110 degrees. And then this one right here is 120 degrees. The only arc we don't know is this little piece right here, correct? Could we find it? How would you find it?
Add up the other arcs and then subtract.
Yeah, they all got to add to 360, so subtract out what we have there. 100 and 110. Oh, I'll just do it like this. That's going to be 0, 3, 3. So, yeah, 30 degrees. 360 minus 330 would give us 30 degrees for that little piece. So now we know all the arcs. So I'll just put the 30 degrees on here because we know it. And I bet they're going to ask us that. If I'm guessing, they're probably going to say, find the measure of arc DE. That's the first thing they ask, right? Usually, if you draw the figure, you can kind of figure out some of the questions they're going to ask. So we just found it. 360 minus 330 gave us 30 degrees there. Now find angle A. Okay, so angle A, is it inside the circle or is it outside the circle? Outside. So we take the two arcs. Do we add them or subtract them if it's outside? Subtract. So the two arcs that angle A cuts into are 110 and 30. If you remember, outside the circle, you're going to subtract the two arcs, and you're going to divide by 2. Isn't that what the formula tells you to do? We're either adding or subtracting, and then dividing by 2. So that's what, 80 over 2? And that would be 40 degrees. So angle A is 40 degrees. Okay? Everybody see what we did there? Okay. Now let's look at angle B. Angle B is on the circle. When you got an angle on the circle, do y'all remember what that's called? It's an inscribed angle when the vertex is on the circle. And it's half of the arc that it cuts off. So that would be half, and let's see, angle B, it cuts off this 30 and it cuts off this 120. That's 120, right, if you look at the book. So wouldn't 30 and 120 be 150 degrees? A half 150 degrees is 75 degrees, right? So part of it is looking, the most important question I think with these to ask is where's the angle? Is it on the circle? Is it outside the circle? Is it in the circle? Or is it the center of the circle? We got all those different things we've talked about at this point, haven't we? So, by the way, they're going to ask me for C next. C is also an inscribed angle, but is there an easier way to find C? Yep, all the angles in a triangle add up to 180, and that's the other angle in the triangle, right? So A and B were like 40 and 75. If I take 180 and subtract that 40 and that 75 added together, that's what, 180 minus 115, right? Okay. 65 degrees. Is that right? Y'all think? Okay, so C is 65 degrees. I didn't use a single angle formula there. I went back to what we were doing at the beginning of the year, right? So I could have said it's a half of 30 plus, C is here. If I had used the inscribed angle formula, it would have cut off that to that. So it would have been half of all this piece of the arc, which is a half of 130, and it still would have been 65. So usually there's more than one way to find the answer, and if you kind of look at the big picture here, sometimes you can get away without having to use those angle formulas once you get a couple of them going. So that's kind of nice.